So we're going to go back to solving equations graphically and be a slightly new technique here that we're going to look at. So we've got the two algebraic equations in the bag, right? And we touched on solving graphically. And by the way, when you solve graphically, where do you find the solution to both equations?
Where they intersect.
They do the point where they intersect, right? Okay. So let's take a look at exercise 1. So the equation is 3x minus 2 equals 10 minus x. Does that look like you can break that up into two separate equations that would need to be equal? Yeah. Like one of them could be y equals 3x minus 2, couldn't it? Man. And another one could be y equals 10 minus x. Right? And if you need them to be equal, like they are stated there, couldn't you just graph them and see where they intersect, maybe?
Yeah.
We'll save that for a little bit later. So they want to solve the equation using standard methods and show us a solution by check. So let's just write it down. 3x minus 2 was 10 minus x. Hopefully by now you know how to solve one of these, right? We've got variables on both sides. What do we have to do?
Add 2.
Get them all on one side. They get all the x's on the left and everything else on the right side, yeah? Or vice versa, but you know how I like to do it. So what am I going to do to get all my x terms over on the left side of the equal sign?
Add the x.
We can add x to both sides?
Add 2. I already know what x is.
Okay. And we might as well go ahead and add the 2 to both sides, right? Instead of doing another step, get that over there. It gives us 4x equals
3.
12. Yeah.
My mom has up at 10:45 today, so I'll just be like, I'm here a little bit earlier.
Okay. Then every class for the next 10 years will know about this as well.
Yeah.
So divide both sides by 4, you get x equals 3, right? I don't think we need to go in and check that, do we?
No, baby.
Okay.
Yeah, but it would
So part B. Now they want us to use the calculator and fill out a table here.
These
Okay.
calculators are more confusing than ours.
It's not even that confusing. They're just way too big to hold in my hand.
Yeah.
Anyway,
I forgot how to turn it on.
sure we'll find something else to complain about as we move along, so let's just move along and find that.
I always find something.
So,
Too hot.
you notice how they're going to put both sides of the equation in kind of separately, right? For each one. So let's put in one of them, y equals 3x minus 2.
What
Okay.
are we in? Scratchpad?
Yeah, so, yeah, you can do, I mean, you can open a new document, but for this, it's just hit the little scratch pad button, right? So hit your tab button to get into there. And that's fascinating. Well, I got to change it back to free graph edit entry 1 function. Okay.
Wait, what did we do? Oh, never mind. Yeah. Never mind.
And it was what? 3x minus 2, right?
I
Minus
put
2.
mine.
Well,
It's not even writing. I got it.
what we can do now is have it make a table of values.
I didn't do it.
Didn't do what? Graph it?
Let me see it.
Did you graph it?
I got it.
There's did it.
Did what? You mean that?
Yeah.
Oh, great.
Right.
Right. Okay. So let's make a table of values. Okay? So hit your menu button. What do you think we're going to select here?
7.
7 for table, right? And no, how about 1? Just it'll split. It'll put it off. It'll split the screen. So hit 1.
I don't like that.
So you see this column is X inputs,
Yeah.
and then they have the f of X or Y outputs. What does the table start with over here?
My f of 1, x, 3x, and minus 2 is on the x side.
So this starts with 0. So let's
No, it's not. The x is just really small.
So let's move up, scroll up here till we have an x of 0. Gee whiz, something's going
How do you scroll?
good. Up and down. Oops, I went too far.
Mine froze.
You don't have a table?
No.
Negative 2, 1, 4, 7, and 10. Right? Let's go and put the 10 minus x in to our calculator. So you're going to want to click back over on the graph to select that, right? And then push the tab button. Oops, no, I thought I was in there. There we go. Make sure I'm in here. And, there we go. 10 minus x. So there's the other side of the equation, right? Does it fit on your, like with the intersection? Do you guys see it on your screen, or is it cut off?
Yeah.
All right, we'll work out how to figure that out in a minute. But let's now put a table in for both of them here. So I'm going to delete this table. So go to menu, 7 for table, and then remove table for now. And now put it back in. It should give you another column for the other equation. So menu, 7, split screen table. Right? If I go over. So do you see, whoops.
Yeah, but I have both of them. Yeah, I didn't.
Yeah.
Wait, how do you X out?
So now we got to start at 0.
Menu 7.
And then remove table. So let's copy. So this is our 10 minus x outputs. Right? So let's put those in. We got 10, 9, 8, 7, 6. Okay. Can you guys see from that table where the solution to this equation is? Because remember, both of these, right, we broke them up here, but it's just two sides of an equal sign up there, right? We did them both separately. So can you look at the table and see where the solution is? Where are both sides of this equation the same? Well, what would be the coordinates? 3, comma. So when I put a 3 in for x, what do I get on both sides of the equal sign? 7 is the same output. That's what equal means, the same, right? Okay, so now for C, we're going to want to change our window. Okay? So take a look here. So we've graphed separately y equals 3x minus 2 and y equals 10 minus x, right? Because we wanted them to be equal up here. But our intersection did not fall in our window. So we can change like how wide and how tall the graph is on the calculator. So you all remember that the x-axis is how wide it is, and what tells you how tall the graph is? The y-axis. You'll have a minimum y and a maximum y, and a minimum x and a maximum x. So they're, soon enough you'll be able to figure out how to do this on your own. But here's what they want you to, and I'll show you to do it. Open the x window up from what to what? Negative 2 to 6, and the y from what? Okay, so let's go do that. We can get rid of the table now. So do menu, I guess 2, remove table. Okay. Let's open up our window now the way they said to make the intersection point fit. So they said to do the x's from what, negative 2 to what?
6.
Okay, so again, hit your menu button. Which one do you think we're going to select? Windows, Zoom. There's a bunch of options over there, okay? These are all from 2 down are like these automatic ones, but number 1 is the window settings. So press number 1, and you can type in any, okay? So do you see where it says X-min and X-max? What are we going to put in for X-min?
Negative 2.
And use the negative sign. Negative 2, then just arrow down to what was it?
6.
To 6. Now skip down to the Y-min. That's how tall it'll be, right? And it says to go from what to what?
Negative 2.
Negative 2
to 11.
to 11. Right? Does everybody have that?
Yeah.
Don't have to worry about changing the X scale or Y scale right now. Okay? And just hit enter. So there's our intersection point. Right? So let's go make a quick sketch of this back in our notes. Doesn't have to be exact. All right? What does it look like? It's kind of like, let me just make it closer to right. So it's kind of like this here, and the other one
You are really
like that maybe.
up there.
And it's, I'm not being super accurate here. But how do we find the coordinates of that intersection point on our calculator? Remember?
You just look.
Yeah.
Just look.
Or how do you get the calculator to tell you exactly what the coordinates are? Menu, analyze graph, intersection. Remember, it's going to ask you for a lower bound, so you want to be like to the left of where you can see it. Hit enter.
Menu.
Yeah. Analyze graph, and then slide over to where you're above it and hit enter again. Is everybody able to get the coordinates 3, 7 to display?
Yeah.
Okay. Isn't that what our table told us?
Yeah.
Right? You put a 3 in to either of those equations, and the output is 7. Okay? So this has the coordinates of 3, 7. You good with that?
Mine is a little bit farther up than yours.
It's okay. This is just a rough sketch. All right, this is part D. Fill in the blanks. To solve an equation, f of x equals g of x. Isn't that kind of what we had up here?
Yeah.
Like we had one equation, but we called it this side some function f of x and this one g of x. Graph both sides of the equal sign, right? Found the intersection point. So, well, I just said it, right? We graph both of them and find the what? Intersection. Okay? If you're, do it carefully with some graph paper, you can do this fairly accurately by hand too. You need the calculator. Okay, let's move on to exercise 2. Here's our equation now. X squared minus 11 equals negative 2x plus 4. So let's break this into 2 separate equations, f of x and g of x.
Oh dear.
So what's one of our equations going to be? Y equals
X squared minus 11.
x squared minus 11, and the other one will be what? Y equals,
Negative 2x.
okay, that x squared minus 11, what kind of graph will that be? You guys remember? Straight line? Is it linear?
No. Yeah?
No, x squared. Not linear.
No. I don't know.
You don't remember the name of the graph it'll make?
Um,
No, you.
Oh, you thought? I don't remember how to spell my own name.
Mm-hmm.
That's a little.
Is it with an x squared term we call a quadratic equation?
I don't know.
And do you remember the shape of the graph?
I don't know.
The U-shaped graph
Oh, it's
called
not
a what? Starts with a P.
parallel.
Parabola.
Yeah. Something
So,
like that.
hey, so if we have a parabola and a line, could we possibly have 2 intersection points? If one of them shaped like a U and the other one goes through it twice, maybe? Right? Well, let's find out. So let's graph x squared minus 11. Okay? Thing here. So go into, actually, they gave us a window, didn't they? Yeah, they did. So let's change our window first from x of negative 8 to 8 and y negative 20 to 20. Okay? I'm going here. First of all, I want to clear all that out of there. So I'm going to do menu,
I didn't do that.
actions, delete, yes. I'm going to go menu, window zoom, window settings 1. And they said from negative 8 to 8, so x of negative 8 to 8, down to the y, negative 20 to 20.
Negative 8 to 8.
Have that, yeah?
You're going a little fast.
It's all still up there.
Okay.
You got it?
Okay.
You did,
I got
did
it.
enter? So now let's put our equation in as 2 separate equations. So it's your tab button. Oh, by the way, Here's how we do x squared.
Your thing is going nuts.
Yeah. Here's how we do x squared. Everybody pay attention. Type the x. Do you see this little thing here?
Yes.
Versus x squared.
Oh, wow.
Okay?
Makes more sense.
And it's minus 11. So minus 11. Arrow down and put the other one in. Hey, there's our parabola. And the other one is negative 2x plus 4. Make sure you use this negative symbol. 2x plus 4. So there we go. How many solutions does this have?
Two.
Right? I mean, it could have just maybe touched it one time, couldn't it? It could just have one solution if it touched it once, right? Or if they didn't intersect at all, how many solutions would it have? If the two graphs don't intersect at all, how many solutions would it have? None, right? But this one does have two. I'm going to say let's get rid of this stuff here. Remember how to do that?
Oh my God.
Just click it and hit delete, and then click it, hit delete. Just get it out of the way.
Where's the other one?
You gotta make it.
So let's make a quick sketch of this in our book.
This does not look right.
Oh my god,
So it's going to be roughly kind of like this, right?
Oh,
And then the other one just
wait, no.
down that way through that, like kind of like this, I think. Did I hit that right? Yeah.
Emily's is not looking so hot right now.
Oh. Now let's go find one of the intersection points. So where are we going for an intersection point? Where are we going to go to find an intersection point? Menu, analyze graph, intersection. So we got to slide. Let's get this one over here first. So let's get our lower bound for that one. We're telling it it's in between here and the up and here.
Negative 514.
Negative 514. So let's go over here, put this point in here. So that's at negative 5, comma 14. And then we'll find the other one. So menu, analyze graph, intersection. I'm already to the lower, so you enter, and I'll slide over to the other side of that one. 3, negative 2. Everybody? Okay. So this is at 3, comma, negative 2. And if we plug both of those in here, right? So by the way, what are the x values that are the solution to this? X equals what?
I can't tell what that's.
Negative 5. Or x equals what? What's the other x value?
I can't.
3. So these are the two solutions to that equation up top.
3 negative.
All right? Get the idea here?
No.
No. What's the matter? What are you not getting?
The calculator is just messing up.
Are we gonna use it for a homework? I don't think it's a calculator.
All right, let's go to the other side. So now we have, and they've already graphed it. What is this function in exercise 3? Read that. F of x equals what?
The app.
Well, equals something before what? 2 times the absolute value of x plus 1 minus 8 on the outside, right? And they put that graph over here already, okay? So they want us in A, find all values that solve the equation shown below. So in other words, this equation equaling 0. Well, where will it equal 0 on the graph? When the graph hits what?
Oh, gee, I was having trouble with.
When the graph hits what? No, the graph doesn't hit the origin.
The 15.
Where do you find y values of 0 in the graph? Here's the y-axis. Where do you find y values of 0?
Wait, y values of the
Yeah.
Y-intercept.
anywhere on the x-axis.
Anywhere on the x-axis
Oh.
is a y value of 0, right? So to solve this graphically, it's going to be where the graph intersects the what?
Y.
The x-axis, right? So there's a solution to that equation there and there. What are those x values where that equation equals 0? X equals what?
Negative
5. What word do I put here?
3.
What word do I put here?
Or.
Or x equals 3. So those are the two solutions to that particular equation. Okay, let's look at part B.
That was what we just had, wasn't it?
Yeah, I guess it worked out to be the same
Yeah.
function. Anyway,
I'm sure that.
part B, final value of x to solve this equation. Now we have the 2 times absolute value of x plus 1 minus 8 needs to equal 2. So we could graph both of these sides of the equation, right? So we could graph y equals 2 absolute value of x plus 1 minus 8. And what would be our other equation to graph? Y equals -2. Hey, what kind of graph is y equals -2? What axis does it cut through?
EY.
And where does it cut through it at?
Negative 2.
So let's go, we already have this one graphed. Let's go graph y equals -2. Right, it cuts the y-axis down here at -2. Right, isn't this the graph of y equals -2? Okay. So now do we see solutions to this equation since we have both sides of it graphed? Where are they? Yeah?
Negative 2, negative 2. Or
Negative 2.
Okay, so what are the x values of our solution?
Negative 4. Negative
It's like 1, 2, 3, 4, -4, or x equals what? 2. Or intersects the line y equals -2. Okay?
Mine looks like 4.
All right, let's look down here. Find all values of x to solve this equation. Now we'll have a graph which is already up there. Y equals 2 times absolute value of x plus 1 minus 8. And what's the other graph? Y equals
-2. Negative 1.
y equals x minus 1.
Oh, I got it right.
Yeah.
That first.
So let's graph this. What's the y-intercept of this x minus 1 equation? mx plus b, right? What's the y-intercept? What's the b? -1. What's the slope? Up 1 over 1, right? Isn't it? So up 1 over 1 is basically, right? And you probably want to use your straight edge, right, to be accurate here with this. Like that. So we'll get our straight edge out here. Oops, do a line. That. Whoops, that one. This dumb thing didn't give me arrows. But anyway.
I drew a straight line in the wrong spot.
Wait
Yeah.
a second.
Somehow it didn't give me arrows there. So we have this graph here. So here's our graph, y equals x minus 1. All right. So do we see the intersection points now? Here and up here?
No, I can't even like see. There's
Well.
so much dots and lines.
Okay.
Okay, so it's gonna be 5,
So the x values are what?
5, and -3.
So negative 3 or x equals 5.
Oh my gosh.
And if we plug negative 3 in for x, it'll make this true. If we plug in 5 for x, it'll make this true.
Why'd you
If
say
you're really
that?
curious, I'll let you check that on your own.
That was the most unstraight word ever.
All right, let's move down here. So we have two things graphed. What's that one that's curvy? What do we call it?
Parabola.
Parabola. It's got an x squared in it, right? And the other one is what kind of graph? It's a linear equation. Hey, here they are, right?
Yes, it's number 4.
So we don't need to guess. Which of the following sets gives all solutions to negative x squared plus 4x equaling 4 minus x? And well, both sides of the equation are graphed, right? So here and here. And they're displaying it in set notation. I guess that's okay. So what's the choice?
X equals 1 or
Right?
equals 4.
So this is 1 comma 3, and this is what? 4 comma 0, right? So what's the correct choice? X of 1, X of 4, right? This is X equals 1 or X equals 4. They just have it in set notation. All right. I do want to give you a quick, because this book doesn't do it. I think it's a handy way to graph by hand. You know how some equations, linear equations, if they're not in y equals mx plus b form, like to graph them, you got to put them in that, find the b and find the m. Right? There's another way, and I'll just ask you, how many points define a line, guys? 2 points. So if I had a line in my grid, and the line crosses the y-axis and it crosses the x-axis, wouldn't those 2 points where it crosses the axis be enough to make your line? Those are called the intercepts, the x-intercept and the y-intercept. You like B is a y-intercept, right? So here's how so graphing using intercepts method, or just intercepts, okay? Hey, when a graph crosses into the line, the graph, and where that line crosses the x-axis, what's the value of y at that point? When it crosses the x-axis? Huh? 0, isn't it? Now, where the graph crosses the y-axis, what's the value of x? 0. So whatever axis it crosses, the other variable has to be 0, doesn't it? So could we just plug zeros in for 0 in for x and 0 in for y and get those two intercepts?
Yes.
So what you do is you find the x-intercept, and that's where y equals 0, yeah? And then you can find the y-intercept. That's where x equals 0, you just told me, right? And then you connect those two with a line. Let me give you an example. Here's an equation. It's a graph. 3x plus 5y equals 15. Now normally, and you can still do it, you know, you've got to solve this for y and get it in y equals mx plus b form, right? Get your m and your b. But this is just another way. A lot of kids like this better, right? So let's find the x-intercept. What's the value of y at the x-intercept? If I put a 0 in for y, what happens to this whole term? And what's left? What I have left is 3x equals 15. So what does x equal? 5. There's my x-intercept. Now let's find the y-intercept. What do I put in for x for the y-intercept? 3 times 0 is what? And so what's left? 5y equals 15. What's the y-intercept? 3. Let's make a quick sketch over here. X, Y. What was our x-intercept? 5. Put a point. What was the y-intercept? That's a y of 3. Put a point, right? And take your straight edge. There's another way to graph a line without having to put it in mx plus b form. Well, I completely missed that 3, didn't I? Yikes.
Yeah, I don't think you're too good at drawing a line.
Try it up here sometimes. It's challenging.
You
Okay.
got a ruler that you go.
You can't do, you touch the stream with a ruler, it makes marks.
Yeah, but you have a ruler like in the computer thing or whatever you got there.
Anyway,
Whatever you got there.
let's look at some Regis questions.
Yeah.
How to graph stuff. Go to page 143. What's going on here?
Two families went to roller coaster. Girl,
Roller coaster world, 2 families.
the Brown family paid $170 for the children.
So the brown, does that sound like an equation? Right? Maybe C is the cost per child and A is the cost for an adult, maybe? Okay, what about the Pickums?
Plus
The
2A
Peckham family paid $360 for 4 children and 6 adults.
Okay. Well, can we use C and A for this, by the way?
So you have to use X
Why do we have to use X and Y?
because it tells you to.
Because the Regis question says A, you gotta use what they say to use, right? So let's, if X is the child, right? And Y is the adult price.
They should have done like 2 is Y.
Let's-
or 3 is Y because
It,
you
yeah. Let's do an equation for the Browns cost. What would it be?
3x plus 2y equals 170.
2Y equals 170. Okay. And how about for the Peckhams?
4 6y
Plus 6Y equals 360. So there's the first part. There's our system of equations, right? And both of those have to be true at the same time. Yeah? Now what do they want us to do? Let's graph them. You want to try our new intercepts method?
No.
I do. Let's take the Browns. 3x plus 2y equals 170. Let's find the x-intercept. It would be 3x equals 170. Get your calculator, what's x equal?
Yes, I can hit it.
Divide 170 by, both sides by 3. I bet you it's 56 2/3. Hit Control Enter.
I don't like
Try
that.
Control Enter. Did you get an x-intercept of 56 2/3?
In your world, we did. In world,
Wait.
Are you using the yellow calculator? So, all right, do 170 divided by 3 and then hit Control Enter instead of just Enter. Try that.
Mine. Oh. Mine's come off already.
Mine's like S1 something 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 like that.
Okay. Let's try the y-intercepts. I put a 0 in for x. What's left? How's that? 2y equals 170. What does y equal?
85.
85. Let's graph this line and use your straight edge. If you don't have a straight edge, get one because you want to be accurate with this, right?
Can I put this calculator away?
No.
No.
So let's go out here. Well, we're going to have to estimate 56 2/3. There's 50, 55. Be about here, wouldn't it? That, roughly? Huh?
Just grab a bunch of it.
55 would be right on that line in between them.
Oh, good.
Yeah, I think it's 56.
It's 56 2/3. Now go up here to 85. Let's connect these. Like that. Straight edge. Now let's take the other equation. 4x plus 6y.
We're not there yet.
360. So you guys find the x-intercept and y-intercept for these.
Have you ever had a student not know how to use a ruler?
Yeah.
He's definitely thinking yes.
What is that? What's the x-intercept for this one?
Hang on.
360 divided by 4. 90. Yeah. Now let's do the y-intercept.
Can we take a minute? Look here for it. It literally looks like it goes into that.
Wait, can we take a minute? 'Cause I am a little bit behind. Yeah.
Can you take a minute?
What's the y-intercept?
Wait. 6, D, 60.
60.
6, G, 60.
So let's go on the x out to 90. Right there. And on the y up to 60. Take a straight edge.
Wait.
Connect them.
I don't think I see the number.
Oh my gosh.
What's it say 90 on the freaking thing?
And now let's make sure. We've got two graphs in here, right? We should label them. First one was 3x. Wow. Switched over to that suddenly on that one. Plus 2y equals 170. And the other one was 4x plus 6y. 360. You guys see where the intersection point is there? Okay.
It's at 30, 40.
So it says state the coordinates of the intersection.
30, 40.
It's right here,
30, 40.
30, comma, 40. So the x is 30 and the y is 40. What does that mean?
I didn't get that.
This point right here, go over 30 and up to 40?
I did not get that.
I
Okay.
didn't get it.
We'll just say.
Well, did you graph the two lines?
Yeah,
I don't know how you couldn't get it because I have it right here. You just,
I got it.
I got it.
okay. What does that mean then? What does the fact that 30, comma, 40 is the intersection point mean in this problem?
When the Y is 0.
Well, I don't want to talk about x and y. What does x reference in the problem?
The children ticket the
Children ticket price, and the y was, so what does 30, 40 mean?
That's how much.
30 was for the children.
30 what?
30 tickets.
$30.
So a child tickets cost what? And what else?
Adult tickets probably $40.
Adult tickets cost $40. Okay? Now you could have graphed those, you know, y equals mx plus b if you like.
It's roller coaster.
I wanted to show you the other way to do it.
I like this one better.
You could have put them in your calculator and got some points of interest as well. Put them on there.
Oh, no, that.
Reincarnation. Oh, recreation.
All right. Let's take a look at this. Regents question number 2. I want you guys to read it over on your own and see if you can generate the system of equations that they're looking for. And notice what variables they say to use. And you've got to think about what you know about bicycles and tricycles.
Yeah, bicycles!
For the total number of bicycles and tricycles altogether.
3D.
No,
Really? You guys
just the,
T plus B equals 15.
we'll say that one more time.
T plus B equals 15.
T plus B equals 15, right?
Sure.
Now, Wheeler, give me an equation for the total number of wheels.
3T plus 2B equals 38.
So each tricycle has 3 wheels, so it's 3 times the number of tricycles plus 2 times the number of bicycles gives you 38 wheels. Now we have a system of equations. Hey, how about this first one to graph it? Wouldn't the intercepts method be real easy?
No.
What's the t-intercept? If you put a 0 in for b.
Oh, you have a towel there.
If I put a 0 in for b, what's the t-intercept?
0.
15.
I have no idea.
15.
Can we solve this algebraically?
It crosses the, look at the axes, by the way, on the thing. It's a t-axis down there, b-axis there, so x and y.
I don't know.
It's going to hit the t-axis where b is 0. When b is 0, what's left up here?
15.
T equals 15, right? And what's the b intercept?
B equals 15.
It's supposed to be easy. So graph it. 15 here,
I don't know what I'm putting.
15 here. Draw your line.
This is so hard. I wish that aren't.
What the heck? Right on.
Again, if you don't stop, I'm gonna bark at you.
Oh,
This can't be that difficult. There's right, connect the 2 dots, the t-intercept and b-intercept. And now I'll let you graph the other one, whatever way you like. You can either find the intercepts for it, or put it in y equals mx plus b form.
I like forming.
So you gotta know them all. So take this one, either get the intercepts or solve it for t.
38 divided by 30. 51.
Let's find the t-intercept, I guess. Put a 0 in for b. What's left in this one?
3t equals 38.
What does t equal then?
Oh no, it's not.
It's not right for I don't know.
12 and 2/3.
Yeah.
Now let's find the b-intercept. Put a 0 in for t. What's left?
2 t equals 30.
What's the b-intercept?
I'm gonna guess 14.
Hang on.
Am I wrong?
19.
19.
I knew it was 19.
So let's go out here to 12 and 2/3. 7, 12, and so about there. And then up here to 19. Connect them with a straight edge, unless you did it with mx plus b form. Get all this in here somehow.
Oh, yeah. T equals 12 and what now?
Yeah.
Okay?
12 and 2/3.
Okay. I got 8.
What is the intersection point here? Right? That is 8, 7. T, B. So how many tricycles did they order? And how many bicycles? Okay, let's take the question down here. Based on your graph, could the recreation center have ordered 10 tricycles?
I don't know. Who would buy 10 bicycles?
Look at your graph.
Oh my God.
No, they don't. There's nothing for extra bikes in the problem. So that's why we graphed it.
4 bikes.
How are we going to find out if they can? What axis has the number of tricycles? One on the bottom, right? So this would be 10 tricycles, yeah?
Yeah.
Okay.
4.
Well, what would be the output for that then in bicycles?
4 or 5.
Huh?
4 or 5.
Could be 10.
Careful.
See what I'm doing here?
Yeah, it's 4.
Could be 10, comma 4, or what?
10,5.
Or 10, comma 5. How many did they order all together?
Either 10,4 or 10,5. I don't know.
Oh, yeah? But will that make both of the equations true? No. How many total things is this all together? 14.
You guys are so dumb.
But how many did it say they bought?
15.
So this is not possible, is it?
No, it's
10,5.
10,5.
It's 10,5.
No, it's not. They bought 8 and 7.
Oh.
8, 7 is the only point that makes both of the equations true. Right? If we go to 10, 5, then it's going to violate the wheels one, the number of wheels, isn't it? Okay, what's 10 times 3?
30.
What's 5 times 2? That's 40 wheels altogether. It said 38.
It's only all
So it
bikes.
can't be either of those points. Could not make this true.
So 9 bikes and 5 tricycles.
No, 8 plus.
It's 8 tricycles and 7 bicycles.
So it's 8, 7?
Yeah.
They just have an extra.
No, they don't. Because the problem says 38 wheels altogether. You can't just make things up. That's your parameters right there. So you get, hey, so this one violates the number of wheels. This one violates the number of bikes altogether. Right? So could they have ordered 10?
No.
No. Let's explain that. The only way to make both equations true is with what? There, it would tell 8 what? The only way to make both equations true is what? To have what?
8 tricycles.
Oh my god, I can't.
Is with 8 tricycles and 7 bicycles. If you have 10 tricycles, it's going to violate either the number altogether or the number of wheels. Okay?
Literally hate this class.
So,